transformation, and matrices, right? So primarily these types of jobs can be performed using NumPy. So I'm going to share my screen. One minute. Can you all see my screen? You can ping in chat. Okay, good. So like array basics, right? Basically, if you want to create some arrays, first thing you need to do is import this library numpy. So import numpy. Okay. So once you import numpy, let's execute. Okay. We can create a array like this is a name that I have given. You can give as your own choice, like my array or whatever, right? A new array something. It's equal to numpy. So this library numpy dot array. Okay, and then you need to write the elements inside the list, like say 1, 2, 3, 4, 5, right? And then we are printing ARR. So what's this? So first of all, we are going to create an array, okay, one dimensional array, and then we are going to store it in ARR, and we are going to print ARR. So 1, 2, 3, 4, 5. So though it looks like a list, but it's an array. Okay. Now, like you can directly import libraries like this, import NumPy. So remember one thing here, I needed to use NumPy, the, the whole word. Okay. In Python, the standard is like we can import the libraries using some aliases. Okay. So like importing NumPy with alias NP. Now, someone of you can ask me like, can we use different name? Yes, you can use different names also, but it's a standard in Python that we give NP name for NumPy, PD for pandas, okay, etc. Matplotlib.pyplot as PLT like this. So import NumPy as NP. What it does is it imports NumPy library and assigns to NP. So we need to just call np.array, not full word. Let's see how it works. Okay, so now we can do the same thing as above, like array equal to. Now I do not need to mention the whole word numpy since it is already imported in np. So np.array 1, 2, 3, 4, 5 print error 1, 2, 3, 4, 5. Right. So np works if we import the numpy library as alias np. Now suppose you all may have different np versions, numpy versions installed in your system. Okay. So how to check the version of the library? So print np dot underscore underscore version underscore underscore. This gives you the current version. Okay. Like in Google Colab, this is the version installed 1.19.5 of NumPy. Right? Now, let's say to check the data type of the array, what we are going to do is we're going to create the array 1, 2, 3, 4, 5 print and then print type of array. So this prints the type of the array. So class numpy.nd array. This means numpy n dimensional array. Here n equal to one dimensional array. I'll talk about it like what is two dimensional array, what is three dimensional array, etc. Okay. Now so far you see that we have used list elements to create the array. We can use tuple elements also to create the array. Okay. Same way, like import numpy as np array equal to np dot array of this tuple elements 1, 2, 3, 4, 5 and print array. This will give you the same array. Okay. Right. So far clear, right?
Yes.
Okay. Okay. So what is the difference between list and array? Okay. So see, list is always one dimensional, right? List is always like this one dimensional. Um, but array is like it could be multi-dimensional. It has rows and rows and columns also. So basically, array we use for data storage. Okay, list we use for variable storage primarily. So these are the primary difference between list and array. Okay. Now say how to check array dimensions. Okay. So like if I want to create a zero dimensional array, what is zero dimension? Zero dimension means a constant element, a single element. Okay, so import on numpy as np array equal to np dot array or just a single element. If I print it, it will be printing 50. So this is a zero dimensional array. Why array? Because I have defined np dot array of 50. That's why it's array. Now one dimensional array you already know it. That's why I'm not repeating. This is 1D array. And what is 2D array? 2D array is like it will be having two dimension, like say rows also it will have, columns also it will have. So rows cross columns. So import numpy as np array equal to np dot array. So there are two lists, and then this is one list, this is another list, and then list of lists. So this is the list, right? So how it treats numpy treats is this is the first row and this is the second row. So print array 1 to 3. This list is the first row and this list is the second row. That's why it has x dimension also, y dimension also. So this is 2-dimensional. Okay. Now let's say we're going to create a 3-dimensional array. Okay. 3-dimensional array, what it will have is it will have, see, what we are going to do is this is a list, this is a list, right? This is a list. Sorry, this one. So this is a 2D array, right? Again, we are going to define a 2D array. This is one 2D array, and this is second 2D array. And this entire list, the final list, entire list of two 2D arrays, if we define like this, an np dot array, that becomes a 3-dimensional array. I'll show you how. So why 3-dimension? It has 3 dimension because this is the first matrix, this is the second matrix. So m cross n cross p kind of. Okay. So this is first matrix, this is second matrix. First matrix, it has 2 dimensions. Second matrix also 2 dimensions. So this becomes a 3-dimensional array, like row, column, and position of first matrix, position of second matrix, and so on. Right? Index of first matrix, index of second matrix. So 3 dimensions. Once you create these arrays, a 0-dimensional array, 1-dimensional array, 2-dimensional array, 3-dimensional array. Now to check that whether these are really 0D, 1D, 2D, or 3D, let's check. So I'm going to create like say import numpy as np. Remember, so you might be seeing me that calling this function repeatedly. This is not required since sometimes I run codes randomly. That's why import numpy as np need to specify before executing this np dot array. But otherwise, as per the Python standard, you just define at the start of beginning of the code. Okay, that's one time call for all the libraries, required libraries, and then you can start coding as you proceed move forward. Okay, so a equal to np dot array 42, b equal to np dot array, this is 1D array, c equal to np dot array, this is 2D array, d equal to, this is a 3D array. So now if I print a dot ending, okay, so what it does, n-dimensional means it prints the dimension of, I mean, a, b, c, d. So print b dot ending, print c dot ending, print d dot ending. Let's see how many dimensions it has. A has 0 dimension because it's a constant element. B has 1 dimension because it's a 1D array. C has 2 dimension because it is 2D array. And D has 3 dimension, I mean 3D array because it's a 3D array. N dimension equal to 3 because it is a 3D array, right? So I see a chat. Okay. So hope it's clear, like different dimensions for these 4 matrices. Now let's say we can create a higher dimensional matrix also. Okay, higher dimensional matrix like say 5D array. How can we create it? So this you know, I'm not repeating. Error equal to np.array. So this single list, but dimension is 5, n dimension equal to 5. So what will happen is, okay, the other dimensions will be blank. Like say, if we print array and print number of dimensions arr.ndim, right? Let's see what it. So like 1, 2, 3, 4, 5. Okay, 5 dimensions, like 5 lists. Okay, and final element is 1, 2, 3, 4. But if you check the dimension, it is 5. That's why it is 5D array forcefully. I mean, it's a one list of elements, but forcefully we are making it 5 dimensions. So this becomes 5D array. So generally we don't require 3D array, 4D array, 5D array. 3D array sometimes may be required, not more than that. So till 3D we may require. And 2D is always we require. 2D is for statistical data, tabulated data. Okay, like okay, 2D is for statistical data, like we store in rows and columns, like so. Okay, good. Now say array indexing. So accessing array elements like list, tuple, set, dictionary, we can access, right? Similarly, and obviously we need to access elements from array because we want to understand like what data we have stored, and sometimes we need to make some operations, right? So let's see how to do that. Array equal to np.array. This array we are going to create. Now, can anyone of you tell me like, so print error 2, what will be the value? Or say print error, say 1, what will be the value? Anyone? I mean, who does not know Python?
21.
21, right? Because this is 1D array. Remember, this is 1D array. That's why I need to pass only 1. I'll show you one by one. You will understand. If it is 2D array, I needed to pass 2 elements and 2 parameters. If it is 3D array, I needed to pass 3 parameters. So print array of 1 index 0, 1. So 0 index is 10, 1 index is 21. So it prints 21. Okay. Okay, so I have already done that. So let's say print third element. Third element means index 2. Remember, index uh, plus 1 is the position of the element. So 2 index means 0, 1, 2. So third position. So it will give you 3 for this array, right? Okay. And how to access the third and fourth elements? And you can add, right? So you know, third and fourth element means array 2 plus array 3, print it. So directly we are adding the values and it will print 7 because array 2 is 0, 1, 2, 3 and 0, 1, 2, 3. Array 3 means 4. So 3 plus 4 equal to 7. Right? Now that's how you can access elements for 1D array. Now how to access element for 2D array? Let's create a 2D array. Array np.array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, print array. And say I want to like say, so array 0, 1, as I mentioned, like I need to pass 2 parameters for 2D arrays because this is for row, this is for column, this is for row, this is for column. So let's see. Basically 0, 1 means, so this will be rows, right? So this is the 0th row. Okay. Okay. Remember here, I mentioned in terms of list, tuple, those things, but in terms of array, this will be 0th row and 0 index row. This will be 1 index row. This will be 0 index column. This will be 1 index column. This will be 2 index column. This will be 3 index column. This will be 4 index column. So when I'm talking about array 0, 0, 1, that means take from 0th row and 1 index column. So this will be 2. So 0th row and 1 index column is 2. That means first row, remember first row, second column. And here, second row, fifth column. So second row and fifth column, 1, 2, 3, 4, 5, fifth column. So this is 10, right? So either you can think in terms of index position, or you can think of the real position. Index value. So if you think index value, then 1 means this is the 1 row, and 4 means 0, 1, 2, 3, 4. So 10. Right? And if you think from positional aspect, so this is second row and fifth column. So second row and fifth column is 10. So got it? Similarly, how can we access 3D elements? 3D array elements, we need to pass three parameters: row, column, position, and then row, column. So if you create an array like array equal to np.array, as I mentioned, this is one 2D array, this is second 2D array, and again this 2D array we are putting inside the list. This becomes 3D array. So print array. Now, if I want to print say array 101, okay, 101 means this is the position of the matrix. So this is zero matrix. This 2D array is zero matrix and zero index matrix. This is one index matrix. And then after that, we have row and columns, right? So one means this one matrix we are going to consider, and 01 means first row, second column. First row, second column value is 8. Similarly, if I put say can anyone of you tell me what will be the value for 012 for this 3D array? What will be the value? Explain the logic also. Hello? Yeah, maybe you can, one of you can unmute and you can tell. Can you hear me all? Hello? Okay. Yes. What will be the answer?
It will be 6. Sorry, it's 6. Yeah.
Okay. One is saying 5 and one is saying 6. Okay. Let's see. So 0 means zeroth matrix. So this 0th 2D, and then first 1,2 means second row, third column. So second row, third column, 6. Okay, if we execute it, it's not 5. See, if it is 5, then 2. So remember the index, right? So if I would have put 1 here, that means zeroth matrix, second row, second column. Then it would have given us 5. Got it, right? Whoever said 5, 6 does not matter, but let's understand the logic first. Okay, I hope you got it. Okay. Now, there is negative indexing, like I had shown last time. There is negative indexing for arrays also. If I'm going to define this 1D array, my array -5 will be my fifth last observation. So 1, 2, 3, 4, 5. Remember, -1 is the last observation and -n is nth last observation. So what will be -5? 1, 2, 3, 4, 5, 1. Now tell me what will be -2? My array -2. What will be the value?
7.
Right. You are right. So 7. Then you understood the logic. So if I put -5, that means it will be 1. Okay. Now, similarly, negative indexing for array, 2D array is like say last element from second dimensional. Okay, array 1, -1. Okay, this is second last element from second dimension, 1, -2, and third last element from first dimension is okay. So let's see how it works. So array 1, -1 means 1 means second row. One index row is this one, 0 index row this one index row this one, and then -1. So 10, right? Array 1, that means again this row, -2 means second last, so 9. Second last observation from second row. And this is third last observation from first row. Third last observation from first row. 1, 2, 3. So this is 3. Last one is 3, right? Got it? Okay. Now let's move forward. So slicing. Slicing means like accessing say range of elements, those things, right? Now suppose we are creating this array 1, 2, 3, 4, 5, 6, 7. Print array 1 is to 5. This means second element till fifth element. As I told you, this works like closed bracket, open bracket. So one will be included. I mean, one index will be included, but five index won't be included. So it will move forward from one index till fourth index. Whatever value are there, it will print it. That's why it's better to remember this side like second index till fifth. I mean, second value till fifth value. Okay. So like second value is 2, 0, 1. So 0, 1 index, and then it will move forward 1, 2, 3, 4. That's all. So basically 0, 1, 2, 3, 4. Fourth index. That's why it's going to take 2, 3, 4, 5. Got it?